Sorry. The adrenal cortex. The adrenal cortex is a little bit more involved in the long-term stress response. Think, I'm holed up in the Alamo, and I'm going to have to hold here for quite a while. Okay? So the cortisol, the mineralocorticoids, okay, corticotropin releasing hormone up here for the hypothalamus. We're going to see corticotropin releasing hormone again when we get to repro, okay, particularly in terms of what's being released by the fetus. Okay. So long-term stress response over here, water retention and sodium retention by the kidneys, increased blood volume and blood pressure, proteins and fats converted to glucose or broken down for energy, increased blood sugar, suppression of the immune system, suppression of healing. Okay. All things that aren't necessarily a good thing over the long term. It doesn't allow your body to heal and regenerate properly. Okay. So long-term stress, unrelieved, will make you sick. Short-term stress. Short-term, you already know about the fight or flight deal with the sympathetic nervous system. The adrenal medulla functions as an outpost of the sympathetic nervous system. It is innervated by sympathetic fibers from the sympathetic nervous system. And it releases epinephrine and norepinephrine just like the sympathetic nervous system does. The difference is the sympathetic nervous system is releasing small amounts of these hormones just in the synaptic gap. Okay? The medulla is releasing these hormones right directly into the blood, and they're circulating everywhere. Okay? So for massive allergic reactions, for example, we give epinephrine. Okay? Sometimes to stimulate the heart, we give epinephrine. The family name for epinephrine, norepinephrine, dopamine, those types of substances, the family name for that is catecholamine. The family name is catecholamines. Now, there is a tumor that can occur in the adrenal medulla, and it has a fancy, funky name. Pheochromocytoma. A pheochromocytoma is a tumor of the adrenal medulla that causes catecholamines to be secreted all the time or in too large amounts. And the first thing you see is the person's blood pressure is going through the roof and you can't keep it down. Now, there are a couple of things that are really, really hard on little tiny blood vessels. The first thing is glucose, and the second thing is too much pressure. So people with diabetes, they have trashed microvasculature in the heart, in the retina, in the kidneys, in the gonads, well, in the external genitalia. People with high blood pressure have trashed microvasculature in the retina, in the heart, in the kidneys, in the external genitalia. Okay? So one of the causes of unexplained hypertension is pheochromocytoma. Okay? And why do you care? You probably don't, except for that high blood pressure is something that you guys have to worry about as midwives. So being aware of other things that can cause excessively high blood pressure is probably a useful tidbit of information. And I don't know about the NARM review, but on every other board exam I've ever taken, they've had questions about pheochromocytoma. Don't ask me why. There's a hand over here. Yes?
How common is it?
It's not real common. It's a zebra.
Because of where the adrenal gland is on top of the kidneys,
how much does kidney function affect? Is there, how
They
much
do
interaction?
their thing. They are neighbors and they do their thing. All right, now, just by way of explanation, you guys know what zebras are?
No.
Okay, in medicine, there's a saying, if you hear the sound of hoof beats, it's a horse, not a zebra. What that means is that common things are common. Common things are common. That should be a duh moment. But when you are in school, you have to learn not only the common things, you have to also learn all of the weird things too. And so students often, when they hear something, the first thing they pick is the weird thing, okay, rather than the common things. So then they're told, no, that's a zebra. Okay, so that's shorthand for that whole little discussion. All right, remember we said,
I just
yes,
have one quick question. That's a tumor of the medulla.
the medulla.
Okay, thank you.
That's why we don't put guys in the
Really?
Okay. Now, remember, we said that you can have different endocrine organs instructed from various places. They can be instructed from the anterior pituitary. They can be instructed from the nervous system, which we just saw with the adrenal medulla. Or they can receive their instructions from what happens to be circulating in the blood. Okay? And the pancreas fits in that category. The pancreas responds to the glucose that is circulating in the blood. Now, a word about the pancreas. Remember we said that we're talking about endocrine organs. Endocrine organs secrete hormones, and they secrete those hormones into the blood or the tissue fluids. Okay? The pancreas is a weird little beast because it's not only an endocrine organ, it's also an exocrine organ. It also manufactures digestive enzymes, and it secretes those digestive enzymes via the pancreatic duct into the small intestine. So we're going to be talking about the exocrine function of the pancreas when we get to the digestive system. Okay, for today, we're just worried about the endocrine function. Now, when you look at the pancreas under the microscope, and this is not a big enough picture for you to tell this really, but out here, these cells are different than these cells here. And if you look at the pancreas, you see a whole lot of the cells like this out here. And then, kind of spotted through it, you see these other little collections of cells looking like islands out there in this ocean of purple. Okay. So the person who first noticed these little different groups of cells, that person's name was Langerhans. And so he called them islets of Langerhans. And now they're called either islets of Langerhans or sometimes pancreatic islets. Now, why do you care? You care because all the rest of the pancreas out here is producing digestive enzymes. The endocrine function, the hormones, are being produced by those pancreatic islets. Now, those pancreatic islets consist of two types of cells. Alpha cells and beta cells. Alpha cells and beta cells. Corey? Yeah, thank you. The alpha cells produce a hormone called glucagon, And the beta cells produce a hormone called insulin. Now, if you were a chemist who was manufacturing cleaning products and you named something glucagon, what do you suppose that product would do?
Glucose would be gone.
The glucose would be gone. That's not what this does. Okay. What glucagon does is it increases glucose in the blood. Man. What glucagon does is it increases glucose in the blood. Okay. I'm always having to apologize for the people who name things. How's that? Okay. Now, if you were going to increase glucose in the blood, how would you do it? I would release it from the liver. Remember, glucose is stored in the liver as glycogen. Okay, how else?
Wow. Does it trigger the release of the glucose?
Do
Does
what?
glucagon trigger the release of the glucose?
It triggers the release of glucose from glycogen. No, it causes the glycogen to let go of its glucose. Okay, so it triggers the release of glucose. What else? How would you get more glucose?
Are you hungry?
It would make you hungry, give you the munchies so that you would want to eat. Okay, what else?
Fat breakdown?
Fat breakdown. Maybe. Okay, now, fat is not usually converted into glucose because it can be burned on its own. But amino acids are often converted to glucose, and that's called gluconeogenesis. Okay, so we got a whole bunch of gluky business here. So let's. Okay, we've got glucose. We've got glycogen. If you break down glycogen, that's glycogenolysis. Then we've got producing more glucose out of amino acids, and that's called gluconeogenesis. And both of these involve glucagon.
Isn't there a drug named glucagon?
Yeah, don't go there. Just go
That's
to
what I'm
life.
Yeah.
Okay? Okay, so glucagon is secreted when the blood sugar drops, and it functions to increase the blood sugar. Now, under most conditions, glucose is readily available. So we typically don't have too much discussion and problems about glucagon. Okay. Is it possible to have too much glucagon? Yeah. Okay. What does insulin do? Insulin decreases blood glucose, but you need to understand how it does it, because when we talk about diabetes, unless you understand what insulin's actually doing, the discussion doesn't make sense. Okay? What insulin does is it allows glucose into the cell. Okay? Insulin decreases blood glucose by allowing it into the cell. Okay? The cell is what's burning the glucose, right? So insulin decreases the blood sugar by allowing the glucose into the cell where it's actually going to be used anyway. So under ordinary circumstances, these two are going to work together, right?
Mm-hmm.
Okay, the cell needs glucose, so it screams, and then glucagon is produced, and the blood sugar comes up, and insulin is also present, and so insulin ushers that glucose right into the cell, and that makes the cell happy. It stops screaming. But what happens if you don't have insulin?
You just keep getting hungry.
You just keep getting hungry, and you just keep
Your cells keep screaming.
your cells keep screaming, and you start breaking down glycogen. Okay, and you start breaking down proteins to make new glucose. And what does all of this do to your blood glucose level? Increases it. But is anything getting in there to that cell to burn? No, so the cell keeps screaming, and the process continues and continues and continues until you have a sky-high blood glucose level. Okay, now, we said that glucose trashes small blood vessels. It does. Okay? Glucose also depresses the immune system. So, diabetics develop things like heart disease and retinal disease and kidney disease and peripheral vascular disease. And they also don't heal well, and they're susceptible to certain types of infections. That's part of the reason they get diabetic wounds, yes. Okay. So, for insulin or for glucose to be used, you have to have insulin present so the glucose can get into the cells. Now, what you see when somebody doesn't have insulin, you see somebody who's very hungry. So that's called polyphagia. You also see somebody who is peeing a lot, which is called polyuria. And if they're peeing a lot, they're going to be losing body water, and that's going to make them dehydrated and thirsty, and that's called polydipsia. So these are the three classic signs of diabetes. Now, why do they have polyuria? The reason they have polyuria is because of osmosis. What's the quick and dirty definition of osmosis? Water follows the particles. If you have a ton of glucose in the blood, that glucose will spill out into the urine. Okay? It won't be absorbed back into the blood because in the kidney, you have little transporter molecules. The little transporters carry the glucose from the urine back into the blood so you can use it. Well, if there's not enough transport molecules, you can't get all that glucose back into the blood. You probably wouldn't want it there anyway because you got too much glucose. But either way, the glucose spills out into the urine. And because of osmosis, it pulls a bunch of water with it. Okay? So spilling sugar means that you have so much glucose in the blood that your body can't keep it in the blood, and it's spilling out into the urine. When it spills out into the urine, it's going to pull water with it. Okay?
I've heard that in some cases the urine will actually smell sweet,
Yes.
and like people would taste it.
Yes. Okay. So the name of this disease here is diabetes mellitus. We heard of another diabetes disease. What was that? Diabetes insipidus, which has to do with antidiuretic hormone, right?
Mm-hmm.
This is called diabetes mellitus. Mellitus is the Latin word for honey, or is related to the Latin word for honey. So, and it got its name because back in the day they used to taste urine, and if there was a whole bunch of glucose in it, it would taste sweet. Okay?
Isn't that similar to maple sugar?
No, maple sugar urine disease is a genetic disorder, not an endocrine disorder. and what they are spilling in their urine is a different type of sugar.
So with preeclampsia, you test for protein in the urine. Are you spilling protein?
Yes.
So, but they tell you to. They don't know this as conclusive to help, but they tell you to have a higher protein diet in pregnancy to prevent preeclampsia. So
They don't know. They don't know what causes preeclampsia.
yeah.
All right. Now, where was I? Diabetes mellitus. Okay. Now, there's a couple of types of diabetes. There's a couple of types of diabetes. Everything in anatomy having to have more than one name. And then you have more than one disease. Diabetes mellitus number 1, or type 1, is called insulin dependent diabetes. In the past, it was also called juvenile onset. What is thought to happen here with type 1 diabetes, the individual develops a viral infection of some type. The body attempts to respond to the viral infection and in the process develops antibodies that trash beta cells. So it's sort of like a friendly fire incident. What's a friendly fire? When you shoot your own troops. Okay? So with type 1 diabetes, it is thought that what happens is that the person develops some type of a viral infection and their immune system responds in a way that causes their beta cells to be taken out. Another variation of that theory is that the viral cells themselves take out the beta cells. Either way, they don't have any beta cells. So are they going to be able to produce any insulin? No. Okay. Now, when are you exposed to most of your viruses? When you're young. So this type tended to occur in kids. Okay. Tended to occur in kids and young adults. Okay, so that's how it got the name juvenile onset. It's insulin dependent because they don't make any insulin at all. And what you see is polyphagia, polyuria, polydipsia. Now, Kitty mentioned fats. If you can't burn glucose, what are you going to burn? Fats. Okay. So if you start to break down fats, what happens to your body weight? It goes down. The problem with fats is that they don't burn clean. Okay, they have a byproduct. The byproduct of burning fats is a chemical called ketones or keto acids. Ketones are acids, keto acids. So your body, in a sense, is starving in the midst of plenty of glucose. And so your body reacts as if it's starving and burns your fat stores. And a byproduct of burning those fat stores is the production of ketones. The problem is ketones are acids. And your body has to maintain your pH within a very narrow range or things really start getting screwed up. So people with type 1 diabetes are susceptible to diabetic ketoacidosis. Okay, diabetic ketoacidosis. Now, this is going to affect brain function. Diabetic ketoacidosis is going to affect brain function. Ketones Your body will try to get rid of ketones any way that it can because there's too many of them. The first place that the ketones are going to go is the same place the glucose went, into the urine. So in addition to having glucose in the urine, you're going to see ketones in the urine. Okay? You also may be able to smell ketones on the breath. They smell like acetone or nail polish remover. Okay? Now, if you've got somebody that you know is diabetic and they're passed out somewhere, the brain primarily runs on glucose. So if you don't have enough glucose, if you are hypoglycemic, the brain doesn't function well. If you have too much glucose and you have acidosis, the brain doesn't function well. So if you've got somebody passed out and they're diabetic, how do you know what's the matter with them? One way is you can smell their breath. That may or may not work real well.
They usually urinate on themselves. So you can actually smell
You may or may not be able to see or smell urine. Do you treat them any differently in an emergency situation? What do?
They put on the sugar.
You give them sugar, okay? If they're still conscious enough to swallow, you pour the orange juice down their throat, okay? Okay? Because if they have diabetic ketoacidosis, are you going to fix it by pouring orange juice down their throat? No. Okay. But the glucose is already so high that just adding, a glass of orange juice is not going to really make it all that much worse. Okay. If they have hypoglycemia, on the other hand, and you give them orange juice, you fixed it. Okay? So when people are having consciousness problems, level of consciousness problems, and they're diabetic, you give them sugar, and then you figure out what's the matter with them. Okay? All right. How do you fix diabetic ketoacidosis? Insulin, and usually they have to be in the intensive care because they've had such fluid shifts. Okay? The ketones and the glucose are pulling water into their vascular system and then out, and they usually have electrolyte abnormalities as well as fluid shift problems. So you have to replace, you have to use an IV drip with insulin in it and enough glucose in it to keep them functioning and straighten out all of their electrolytes at the same time. So diabetic ketoacidosis is usually an ICU sort of situation. Jennifer?
So, people that do the Atkins diets, aren't they at risk for something like it's still ketoacidosis, but it's not diabetic, right?
Correct. It's because they're not eating carbohydrates, so they don't have a source of glucose.
And then it burns all the fat.
Yeah. Okay. So yeah, you can have people that are trying to do a strict Atkins situation who end up in ketoacidosis in the emergency room. It's not diabetic ketoacidosis. Okay, now, teenagers will do this deliberately, okay? Because when they don't take their insulin, what happens to their weight?
It drops.
It drops.
About that.
Okay, and sometimes they will do it just to be brats too, okay? Just because it causes a big disruption in their life and scares their parents to death and all that. Okay, is that a good thing? Absolutely not. But then a lot of things teenagers do aren't very good things. All right. Now, type 1 diabetes, it's insulin dependent. The beta cells are gone. There's no insulin being produced. Type 2 diabetes is different. Type 2 diabetes is different. This one is called non-insulin dependent, or sometimes it's called adult onset. The problem is nowadays we're actually having kids developing type 2 diabetes. Remember we said that insulin is what causes glucose to cross the cell membrane so that the cell has glucose to burn. Well, what if you have so much glucose and so much insulin that the cell is getting too much glucose. First, the body's going to try to store that glucose as fat. Okay? And then eventually, the poor little cells are going to be going, no, stop, we got enough, leave us alone. Okay? And the cell may become insulin resistant. Okay? Now, there's a couple of reasons why a person can become insulin resistant. It may be because they're overweight, and that makes sense. Okay, the cells are going, hey, enough, plenty, back off. Okay, stop throwing glucose at me. Or it may be because there's something the matter with the glucose molecule. The insulin molecule. There may be something the matter with the insulin molecule itself. So the cell can be insulin resistant, or the insulin that is present is not real functional. Either way, you end up with too much glucose outside of the cells. And remember, glucose that is circulating in the blood trashes the microvasculature.
So you're saying that, like, basically the insulin is made wrong by the cell?
That's one way that you can have type 2 diabetes. That if the insulin is being made by the beta cells, but it's not being made functionally correctly. Okay? Or your insulin can be made by the beta cells, but the cells themselves are insulin resistant. They're not allowing the insulin to do its job.
But it's not based on the influx where like the insulin's not able to carry the glucose into the cells, and so that's the
Okay? So how do you treat type 2 diabetes? What's the first thing they do? The first thing they do is they try to get the person to lose weight. Okay? Oftentimes with type 2 diabetics, okay, if they lose weight, the problem goes away. Okay? If they don't or can't lose weight, what do they do then? They take a plunger and force the glucose into the cells. Okay? That's what an oral hypoglycemic agent is. Okay? It enhances the action of insulin. It decreases insulin resistance. The glucose has to go into the cells, whether the cells want it or not. Okay? And then ultimately, especially in cases where the insulin's not working correctly, they may have to give the person insulin. So insulin-dependent diabetics are always on insulin. Type 2 diabetics might be on insulin if they can't get anything else to work. Okay? Does that make sense?
Mm-hmm.
Now, it's adult onset because it usually is related to the person's weight or to the way that they are metabolizing glucose. Okay? People who develop gestational diabetes tend to go on to develop type 2 diabetes. So, in many cases, type 2 diabetes is an issue of the person's weight, but there may also be some underlying metabolic screw-ups that's helping the process. Okay? Because with gestational diabetes, you start to see gestational diabetes when the person gains weight as well. Okay? And that's the first thing you do for gestational diabetes is you try to get them to lower their weight, which is hard to do during pregnancy. Okay? Does that make sense? Okay.
So what would cause the cells to make insulin improperly?
We don't know all the reasons why. Okay. We know that there's a genetic component with this. Okay. We also know that there's a genetic component with type 1, but there's actually even more of a genetic component with type 2.
Okay.
from the pancreas stimulates the breakdown of glycogen into glucose. It raises the blood sugar. When the blood sugar starts to rise, either because glucagon is present or because you just ate, when the blood sugar starts to rise, the pancreas releases insulin. Insulin stimulates the uptake of glucose from the blood. That lowers the blood sugar. It also stimulates the liver to take up glucose and to store it as glycogen. And it stimulates the adipose cells to take up glucose and make fat out of it. Okay. So either way, insulin clears it from the blood and stores it or causes it to be burned. Glucagon, on the other hand, causes it to be increased by breaking down glycogen, by causing you to be hungry and eat glucose, or by gluconeogenesis, which also occurs in the liver, and your body takes amino acids and rearranges the little atoms to make glucose out of them. Okay, so when there's not enough insulin, there's not going to be enough glucose into the cells so that the cells can use it. You're going to break down your stored glycogen. You're going to use your proteins to turn into glucose. So you're not only going to start dissolving your fat stores, you're going to be breaking down muscle tissue as well. It's like starvation. All of that is going to result in hyperglycemia. It's also going to result in an increase in the amount of lipids that are circulating. It's going to result in ketoacidosis when those lipids are burned. The hyperglycemia is going to result in glucose in the urine, which is glucosuria, and osmotic diuresis. So you get polyuria, polydipsia, polyphagia. With polyuria, you have a very dehydrated person. With polydipsia is a response to polyuria, okay? But dehydration will result in fatigue, and fluids weigh something. So if you're losing fluid, you're going to be losing weight as well. Okay? Acetone breath, okay, an increased respiratory rate, okay, trying to get rid of that acetone from the blood, nausea, vomiting, abdominal pain, cardiac irregularities. Some of this is from the ketones, but most of it is from the electrolyte imbalance. Okay, central nervous system depression and coma. Okay. All right, now a word on insulin. Back in the day, when a human did not produce insulin, we used insulin from either cows or pigs. Okay, so it was bovine insulin or it was porcine insulin. And that caused a lot of problems because there are people who don't use pork products for any reason. The other problem is, even though that insulin worked, it was not native human insulin, and so people would develop antibodies against it. Okay? So nowadays what is used is called humulin. The genetic instructions for producing insulin have been inserted into a microbe, The microbe is then grown in a vat. The microbe produces the insulin. The insulin is just distilled out of the vat, and it's identical to human insulin. So there's a whole lot less problems with allergies and compatibilities and all of that kind of stuff. Now, you can monkey with insulin in the lab to vary its effectiveness or vary how long it will last in the body. So there are short-acting insulins, there are medium-acting insulins, and then there are long-acting insulins. And what diabetics do, depending on what regimen they're on, sometimes they have an insulin pump, sometimes they have to give themselves shots. Either way, they have to monitor what their blood sugar is actually doing, along with what they are eating and how much activity they have, so that they can guesstimate the correct amount of insulin. Insulin administration is always a guesstimate, and if you play the game correctly, you will not have high blood sugar and low blood sugar swings. High blood sugar swings damage the microvasculature. Low blood sugar swings can, have you in a coma. Okay, so what they're doing is trying to get it in the happy medium there, in the midline. Okay, questions about that?
So what happens when somebody overdoses on insulin?
When somebody overdoses on insulin, they send themselves into hypoglycemic shock, okay, and they can die from that. Okay, now, as we said, we're not going to talk about the gonads until this summer. The pineal gland is a little tiny gland in the back of the midbrain. It produces a hormone called melatonin. It also produces serotonin and other neurotransmitters. And all of these neurotransmitters interact with various parts of the brain, with the hypothalamus, with the limbic system. There are connections between the retina and the hypothalamus and the pineal gland. The important part of that is that light has an effect on the production of melatonin. In other words, light striking the retina is going to affect the production of melatonin. In general, light hitting the retina suppresses the production of melatonin. Now, in general, melatonin makes people sleepy. It's involved in circadian rhythms. It probably does other things as well, okay? But be careful what you read. Okay? About 10 years ago, melatonin was kind of the same thing as human growth hormone. Okay? In other words, it would make you healthy, wealthy, beautiful, wise. Okay? Improve your golf swing. Okay? Everything. Okay? There was tons of nonsense that was written about melatonin, and everybody was out running out getting melatonin. Melatonin can work for people who are having a hard time adapting to when they need to be asleep. Okay? But it doesn't fix everything in your life. And even though we know it does other things other than regulate your circadian rhythm, most of what it does we don't understand real well. Most of what it does we don't understand as well. Okay, so it regulates circadian rhythms. Now, in other animals, circadian rhythms are really important because they are hooked to ovulation. Circadian rhythms aren't hooked to ovulation to that extent in humans. So if you wonder why you have a whole bunch of baby animals running around in the springtime, or why animals breed at a certain time of the year, it's because the length of daylight is interacting with their pineal gland and is changing the amount of melatonin that's produced, and the melatonin is affecting the gonadotropins from the anterior pituitary. It doesn't work that way with humans. Humans have babies whenever. It's really bad with rabbits. Okay. Rabbits ovulate anytime they have sex, which is why there's so many rabbits. Oh my God. All right. Okay, now, there is a lot of discussion about lights and bedtime. Okay? Lights and bedtime. And have you ever heard that teenagers have to sleep late because developmentally their circadian rhythm is shifted?
Mhm.
You ever heard that? I have my doubts, and here's why. Okay? Back in the day when everybody was living on candlelight, okay, were teenagers notorious for not getting up? Not necessarily. You know, a lot of times people got married younger back in that day, and you didn't hear all of this about having to drag them out and having to shift the school day later and all of this stuff. So what changed? What are they exposed to? Technology and unnatural light. Okay? If you have a teenager that's up at 2 in the morning on Facebook, what are they looking at? A screen. Okay? And so it's becoming more understood that the way the light exposure, okay, the screen time that people are exposed to is having an effect on their circadian rhythms, and it's not always good. So what are they telling people about screen time?
Limit an hour before.
Decrease it before bedtime, okay? That way you're not stimulating your pineal gland, you're not shutting off your melatonin, and it gives your body a chance to get sleepy, okay? So bear some of that in mind. Okay, now a bunch of kind of grab bag stuff here with endocrine organs. The thymus is an endocrine organ. It's located in the mediastinum underneath the sternum. We're going to hear some more about the thymus when we talk about the immune system, but unfortunately not much. We know that it produces a hormone called thymosin. We know that it's involved in programming and the maturation of lymphocytes. We know that the thymus gland regresses. You can find it in children, teenagers, less so. By the time a person is old, it's pretty much gone. And so it's not well studied because nobody's going to do studies on kids to figure out what it is that the thymus is doing. Okay? So we know it's involved in immune regulation. We don't know everything that it does. Other hormones. The heart produces atrial natriuretic peptide. We'll talk more about that when we get to the heart. But atrial natriuretic peptide causes your body to get rid of sodium. It's essentially the opposite of aldosterone. The gastrointestinal tract produces a whole lot of hormones that are identical to neurotransmitters. The gut-brain connection is actually a thing. It's not just voodoo, it exists. If you want to trash your stomach, trash your brain. If you want to trash your brain, trash your stomach. The placenta, we said we were going to talk about that in endless hairy detail in repro. The kidney produces a hormone called erythropoietin, and again, we're going to see that in a couple of chapters here. Erythropoietin functions to increase red blood cell production in the bone marrow. The skin produces cholecalciferol or vitamin D. Now, vitamin D for many years has been considered a vitamin. It actually is a steroid hormone. Vitamin D is a steroid hormone. And we've known for a long time about vitamin D's effect on calcium metabolism. It increases the amount of calcium absorbed from the gut. So with a lack of vitamin D and a lack of sunshine, you got rickets and osteomalacia. Easy enough to fix, you just gave the person some vitamin D. The problem is vitamin D has a whole lot more effects that we did not know about. In particular, vitamin D has interactions with the immune system. When we get to micro, the reason why diseases cause disease is because they can get around the immune system one way or the other. If they can't get around the immune system, they're not going to make you sick. Okay? Historically, one of the things that they used to do to diminish disease and to help people recover from disease is put them out in the sun. Okay? And it's now becoming known that in many of these diseases, tuberculosis, for example, the presence of vitamin D enhances the effectiveness of the macrophages that are trying to fight the disease. Okay? So, for many reasons, your body is designed for sun exposure. So the whole business about crawling under a bridge or a cave and never going out unless you're slathered from head to toe with sunscreen, that's probably an overreaction. Okay? So, you do have skin cancer on one end, okay, but the other end, the other extreme, is not any better. Okay? It has effects on your immune system. There's some interesting things coming out about vitamin D and your body's ability to fight cancer, for example. Okay. Again, though, it is very new, and there's a lot of stuff out there that I think is baloney. For example, if you go to a family doctor right now, they all do a blood level of vitamin D, and then they hand you a bottle of vitamin D. And basically what they're doing is shotgunning. Okay? There's no agreement on what a normal blood level of vitamin D is. Okay? Also, they don't know whether giving you a bottle of vitamin D actually produces the effect that they want. They're just trying to cover their bases. Okay? So stay tuned on the whole vitamin D thing. All right, questions?
I noticed when we were talking about melatonin, in the book it said in children melatonin may have an anti-gonadotropic effect. In other words, it may affect the timing of puberty.
Yeah.
So could potentially our increase of technology be affecting, the light and what have
Something
you, be affecting why women are maturing
Something
so early?
is. Yeah, something is.
Mhm.
Because the age of menarche is dropping.
Mhm.
Okay. And there's various theories for that. Okay. One theory is that there's better nutrition now. Okay. Another theory is that along with the nutrition, young women's fat composition is higher. To ovulate, you have to have at least a 21% body fat. Another theory is the hormones that are present in dairy products and meats. Okay. It's known, for example, that kids that are exposed to very little dairy or very little meat tend to have puberty a little later. Okay. So something's doing it.
Also, I
Something's doing
listened to a radio that had two scientists who are studying this thing right now. And they said actually with the meat and the dairy, that the hormones actually don't metabolize the way that you would think, but it's actually the antibiotics do metabolize like hormones. So it's actually
You got both, the double
yeah,
whammy.
yeah,
You
you
got-
have this. So they're looking at they're focusing on antibiotics, and, but they don't know.
Because-
There's a lot of theories, but these are all.
Because hormones are going to be metabolized in the gut in part by antibiotics, and if you give antibiotics, you change the gut flora.
Mhm.
Okay? And then in addition to that, there are plastics that can be metabolized into active hormones. So something's
Yeah.
doing it. Exactly what, they haven't exactly figured out.
Yeah, maybe a combination of a lot of things.
That's
All
what
right.
these scientists are probably a combination.
Now, for your lab exam, what I'm going to be asking you, I'm I'm going to give you an organ, like brain, okay, and I'm gonna have a sticker, like on the pituitary gland or the hypothalamus, and I'm gonna say, what's the name of this? And you're gonna tell me pituitary gland or whatever it is. And then I'm gonna say, name what hormone or name a hormone that this gland produces. And then I'm gonna say, tell me what that hormone does in the body. Or I'm gonna say, tell me what happens to the body when there's too much, or when there's not enough of that hormone. Because if you notice, you've been paying attention so far, we've had chapter 15. Do I have a lot of models for chapter 15? No. The endocrine system. Do I have a lot of models for the endocrine system? I do have the brains and the torso models, but getting 50 questions out of that. Okay. So then we're coming up to what's next? Blood. Okay. I don't have a whole lot of models for the blood either. So, okay, I'm going to have to ask you not just only tell me the name of this piece of plastic. I'm going to have to ask you, what does this do as well? Okay. So as you're practicing for your lab exam, okay, that's what you need to be asking each other. Okay?
Okay.
Alright. And your physio exam is due tomorrow. And we're having quizzes over the chapter tomorrow.
Quiz tomorrow over chapter